Alright, so what we're going to do next is talk about life insurance. Why not? And we're going to do something called expected value. And to set up expected value, we'll come back to this table in a second. I always set it up as a table. The book doesn't do this. And in the table, it could have several columns, but usually only two. And usually what I want to do is I want to label it on the top, what's going to happen, describe it in some way. Um, the second line is, what do you get? Or lose, depending on if you're losing money. And the third line I like to put in the probability of that happening, the probability of the event happening. So we're going to label it. We're going to say what we're going to get out of it. We're going to talk about the probability of the event under it, and then we're going to do some calculations on it. So for instance, if we were going to do a really small example, let's say a casino has a game of flipping two coins. Real simple game. If you get two heads, you win $10. Anything else? You lose $20. So basically you pay $20 to play this game, and if you win you get $10 back and your $20 payment, your play fee. Okay, so what would happen here is label. Now the label would be what could happen basically, which is you either get two heads or you don't. So I mean, simplistic labeling. You don't have to go crazy. Now, what are you going to get out of this? Well, if you get two heads, you're going to win $10. Oh, I shouldn't lose $20. Let's make it two. Get rid of that. Make it $2. $20 would be way too much. And if you don't get two heads, you have to pay the casino $2. Now, if you keep them both positive, that means you're getting the money. So if you're losing money, you got to make it negative. Now, the probability of two heads, if you go to the outcomes, it's, heads, 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 tails, tail heads, and tail tails. So there's only 4 outcomes out of this, and only 1 out of the 4 is two heads. So this is a 1 out of 4 chance. Over here, this is a 3 out of 4 chance, because that's, what's left over if you're not two heads. So the next step is you take the columns for heads, and you take these two numbers, what you could get and the probability of actually winning the $10, and multiply them together. So you get your $10 1/4 of the time, but you lose $2 3/4 of the time, for a grand total of, let's see here, this is 10 out of 4 minus 6 out of 4. That leaves you with $1. So that means every time you play this game, on average, you're going to win $1 on average. Now, you're not going to find a casino average. Spelled it wrong. You're never going to find a casino where the expected value is positive, because they want to win the money. So this casino is going to go out of business really quickly. But this is the basis of how you find expected value. So this winning on average is also known as expected value. And it's not a very hard calculation. It's actually pretty simple. You just have to be really careful with your money amounts, and you have to be really careful with the probabilities. So let's try another one. Let's blank. Here we go. This is a little bit more complex. So, another casino game to make. A container has 5 red marbles, 2 green marbles, and 93 white marbles. If you put them all together, it adds up to 100 marbles. Makes life easy. To play the game, you have to pay $10. You will be given $200 if you pick a green, $100 if you pick a red, and nothing for a white marble. In all cases, you pay the $10 for playing the game. Now, before, you were given back the money for the horse race, you were given back the money for the last example I did. This one, you pay $10 no matter what goes on. This is more realistic to some life situations. And I want to find out what's the expected value of this game. So let's draw this a little bit nicer. Line. So I want to draw a table. And what can happen is 3 things. 1, you could win $200. 2, you could win $100. And 3, you would lose some money because it doesn't pay, well, anything for a white marble. Alright, so what could happen is we're looking for, let's go for the big payout, the green marble, and the medium payout, the red marble, the 0 payout, the white marble. So these are my descriptions of what could happen. Alright, draw another line in here. Now if it lands on or you pull out a green marble out of this bag, you will win $200. So I'll just put, this is what happens if you get a green. If you pull out a red, you win $100. If you pull out a white, you lose nothing. But you do because you have to pay $10 anyways. So because you're taking $10 away automatically, these are what they're going to give you when you win. So you're actually not winning $200 or winning $100. I was really careful with my language. You will be given $200. So what you have to do to each one of these is lose your $10. So I'm going to have like a little more rowage going on here. So one more row. And these are your winnings per se, winnings and losings. So these are important. You have to have your winnings in this, not how much you're given back. So here you would have 190. Here you would have 90. And here you would actually lose $10. Alright, and then the next column is that probability. What is the probability of actually getting a green marble out of this container? Well, there's only 2 green marbles, and there are 100 marbles altogether, so the probability is 2 out of 100. Now, one mistake I've had people do with this one is they assume they take the marble out and then the probability of the next one changes. That's not what's happening. All you're doing is reaching in, grabbing one. If it's red, you win something. If it's green, you win something. If it's white, you don't win anything. So don't change the probability of the red based on the green, because you're only picking 1 marble to begin with. So the probability of red should be 5 out of all 100 of the marbles. And then the probability of white, well, there's 93 of them, so that would be 93 out of 100. So the calculation we want to make is how much you could win times its probability all the way across. So these you're going to multiply together, and you're going to take your answers and add them all up. So this is 190 times 2 over 100. You can reduce if you want, but the calculator will do most of the work for me. Here you have 90 times 5 over 100, also known as 5%. And then you're going to lose $10 93 times out of 100. And if you type this into a calculator, if I remember right, the answer is -1. But let's do it. 190 times 2 divided by 100 plus 90 times 5 divided by 100 minus 10 times 93 divided by 100. Yeah, -1. So the expected value of this game, much more like a casino, would be the patron would lose $1 on average. And what that means is if they keep playing many, many, many times, on average they're going to lose $1 every single time they play. So if a player plays 100 times, on average, the amount of money they win or lose will be down $100 because they, on average, lose $1 every time they play. Now, some of those times they're going to win. They could win big. They could win $200. But eventually, what would happen is, on average, they lose $1 every time they play. And this is how casinos make their money, because they have a lot of people in there, and some people lose, and most people lose, and some people win. But they make a profit no matter if you win or lose, because they win $1 every time someone plays this game. Alright, so how does this relate to the real world? Well, I won't do that one yet.